Okay, so in this question we have a sphere P of mass 3m moving with a velocity of u at an angle of alpha to the horizontal or the I direction. We have another sphere Q which is initially at rest and it has a mass of 7m. So the first thing we should do is we need to resolve the velocity vector u into its I and its j components. So the I component is u cos alpha I, and then the j component is u sine alpha j. And we'll just write down the velocity of u beforehand. So u of p is equal to u cos alpha I plus u sine alpha j. Now, as a result of the collision, the speed in the I direction only will change. The speed in the j direction, u sine alpha, will remain the same. The velocity of q before the collision we said was 0I plus 0j because it's at rest. And similarly, it's only the I component will change as a result of the collision. The j component will stay the same. So after the collision, we have the velocity of A is v1I plus u sine alpha j, and then the velocity of B is going to be vi plus 0j. Now normally this v would be v2, but we're told in the question that the velocity of P after the collision, or the velocity of Q rather after the collision, is v, and so that v is what would normally be the v2. And again, just to emphasize, note that the j velocities did not change as a result of the collision. So if we apply the PCM and the NEL, we have u1 is equal to u cos alpha, u2 is equal to 0, v1 is v1, and v2 we're going to call v. The masses, m1, the mass of the first sphere, is 3m, and m2, the mass of the second sphere, is 7m. So the PCM, first of all, we have m1 u1, which is going to be 3m times u cos alpha, plus m2 u2, which is 7m times 0, is equal to m1 v1, which is 3m times v1, plus m2 v2, which is 7m times v. We can divide across by m, and we get equation 1, which is going to be 3v1 plus 7v is equal to 3u cos alpha, and we label it as equation 1. For equation 2, we're going to set up the NEL. So the difference between the velocities after the collision is equal to minus e multiplied by the difference between the velocities before the collision. We've been given a value of e in the question. E is equal to 2/7. So plugging in the known values, we have v1 minus v is equal to minus 2/7 on u cos alpha minus 0, and that gives us equation 2. v1 minus v is equal to minus 2/7 u cos alpha. So the question is asking me to find the speed of P before the collision. So we're being asked to find this velocity u. So let's first of all solve for v in the question. So I'm going to write down equation 1 as it is. 3v1 plus 7v is equal to 3u cos alpha. And then equation 2, I'm going to multiply by minus 3 to give me minus 3v1 plus 3v is equal to 6/7 u cos alpha. I'm going to draw a line underneath. The v1s will cancel. 3v1 minus 3v1 is 0. 7v plus 3v is 10v. And then 3u cos alpha, we can write that as 21u over 7 cos alpha. And if we add that to 6/7 u cos alpha, we get 27/7 u cos alpha. Dividing both sides by 10, we then get that v is equal to 27 u cos alpha divided by 70. Now again, we're being asked to solve for u. So u is here in the equation, and I am going to multiply both sides by 70 to give me 70v is equal to 27 u cos alpha. And then I'm going to divide both sides by 27 cos alpha to give me 70v over 27 cos alpha is equal to u. And so this is the velocity of P before the collision. The second part of the question tells us that alpha is 30 degrees, and we're asked to find the angle through which the direction of motion of P is deflected. So what that means is we need to find the angle of motion after the collision of P, which we'll call beta, and then the angle of deflection will be the difference between beta and alpha, which we know now is 30 degrees. And so this here is the angle of deflection. So we need to write the velocity of P after the collision. and so we need to go and solve for the I component, which was V1. So the way that we do that is we take our two equations again. I'm going to write down equation 1 as it was, 3v1 plus 7v is equal to 3u cos alpha. And I'm going to multiply equation 2 by 7 to give me 7v1 minus 7v is equal to minus 2u cos alpha. I'll draw a line underneath, plus 7v minus 7v cancels, 3v1 and 7v1 is 10v1, and then 3u cos alpha minus 2u cos alpha is equal to u cos alpha. Now I can sub in 30 degrees for alpha at any stage, but I'm just going to leave it in the question for now, and then I'm going to divide both sides by 10 to give me that v1 is equal to u cos alpha over 10. Now to find beta, we have the velocity of p as u cos alpha over 10I, so we've just found its I component, and then remember its j component is as it was before the collision. The j component here was u sine alpha, and that didn't change as a result of the collision. To find the angle, we're going to have tan of beta is equal to the j component over the I component. So the tan of beta is equal to u sine alpha, which is the j component, over u cos alpha over 10. If we want to divide by a fraction, we can invert the fraction and multiply. So that's u sine alpha multiplied by 10 over u cos alpha. Sine alpha over cos alpha is tan alpha, and the u's cancel. So I have 10 tan alpha. So tan beta is equal to 10 tan alpha. I'm going to sub in the 30 degrees for alpha. So tan beta is equal to 10 by tan 30. And I'm going to throw this into my calculator, and tan beta is equal to 10 root 3 over 3. And then to find beta, I do tan inverse 10 root 3 over 3, and it's a value of 80.17 degrees. So the total value of the angle, the velocity vector of p afterwards, is 80.17 degrees. And so if I subtract the 30 degrees, I'll get the angle of deflection, which is 50.17 degrees. And so the angle we're looking for, the angle we've just found, the angle of deflection, is in here. That's 50.17 degrees.